This is review problem number 5 for assessment number 7. It says find all solutions expressed in radians. Now I want to be specific here. It says find all solutions, and it doesn't give you a restriction like 0 to 360. It's saying find them all. So you're going to end up writing some sort of expression like at the end of your solutions, like plus maybe pi n or something like that. So cosine 2t equals negative cosine t. How do we start the problem? Well, we see that we have cosine 2t, and we know that's double the angle. So we could probably use one of the double angle formulas to start the problem. And the reason we want to do that is we want to get cosine 2t to just be cosine t, or some version of that, so we can do some factoring here. So cosine 2t, I can rewrite that as 2 cosine squared t minus 1. I'm going to pick the middle equation just because that one has cosine in it and has no other signs. So you see the top equation has a sign in it, the bottom one has a sign in it. I want to keep this only one function, so I only want to use cosine. So I'm going to say that this is 2 cosine squared t minus 1 equals negative cosine t. Now you'll notice that I have cosine squared and cosine. So I could probably try and set this equal to 0. So I'm going to move this over. It kind of looks like a quadratic. So I'm going to move this over and say 2 cosine squared t plus cosine t minus 1 equals 0. Now if you don't like how this looks, there's a little bit of a trick that you can use. So we can go through and we can say, what if x equals cosine t? So if x equals cosine t, I could rewrite this as 2. So I'm going to rewrite this as 2 x squared plus x minus 1 equals 0. Now I can try and factor this. So I could have 2x, x. How do I get 1 in the middle? Well, I need the 2x to stay positive, so I'm going to put plus 1 here, minus 1 here. And you can see negative 1 times 1 is negative 1. Negative 1x and 2x gives me the 1x. And obviously 2x times x is 2x squared. So this is my factored form of this. Now once I get to this part, I can then say that 2x minus 1 equals 0, or x plus 1 equals 0. Add the 1, divide by 2. So we'll have 2x equal 1, x equals 1/2. Or subtract the 1, x equals negative 1. And then at this point, because I've now solved for x, well, I know that I replace cosine with x, so I can take cosine and put it back in and say cosine t equals 1/2, or cosine t equals negative 1. And now I can start to figure out, where does cosine t equal 1/2? Well, if I pull out my unit circle, cosine t equals 1/2. We know cosine's positive in quadrants 1 and 2, or sorry, quadrants 1 and 4. So cosine t is 1/2. We go to the x values. We can see that that's at 60 degrees. So we can say 60 degrees for t. We can say that we would have, let's see, cosine 1/2 at 300 degrees. And finally, it says cosine t is negative 1. Well, cosine t is negative 1 at only one spot, which is pi, or 180 degrees. So our solutions in degrees is t equals 60 degrees, 180 degrees, and 300 degrees. Now they want us expressed in radians, so we better write this. And I'm going to write on this side now. And we're going to say that that's t equals 60 degrees is pi over 3. 180 degrees is pi. And 300 degrees is 5 pi over 3. Okay, now we want all the possible solutions in this problem. If you remember, it says find all solutions. Right now we have pi over 3, we have pi, and we have 5 pi over 3. So to find all possible solutions, we're going to want to essentially add 360 to each of these. Right? We want to go around over and over and over again, landing on the same spots. So what we should do is say that this equals pi over 3 plus 2 pi n, comma, pi plus 2 pi n, comma, 5 pi over 3 plus 2 pi n. And the 2 pi n tells us that for every revolution, we want to go around another 2 pi to land on that same spot. So if we spin 10 times, we'd say 10 times 2 pi, that'd take us around that number of times, but we'd land in the same spot each time. And those would be the expressions for your solutions. Now I think when you guys go through and you do the problems, you probably have a multiple choice selection for that in your problem.